Hi everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some fascinating AI research. We'll be looking at a paper titled Unmasking and Improving Data Credibility, a study with datasets for training harmless language models. Basically, the researchers are tackling a really important problem: how errors in the data used to train language models, specifically errors in labeling safe versus unsafe content, can actually make the models harmful. They developed a framework to systematically find and fix these label errors in several popular datasets, finding an average error rate of over 6%. Fixing these significantly improved things, showing just how crucial clean data is. And speaking of the framework, the researchers have actually made it available as an open source tool. If we look here, this is their GitHub page for the tool they call Docta, with the tagline, "A doctor for your data," which is pretty fitting. It's designed as a toolkit to help diagnose and, fix issues in datasets. It includes demos and tools for finding these label errors in text and image data, and it can even handle tabular data too. How effective is this Docta tool at finding those errors we talked about? Well, this table gives us a summary of the label error ratios it detected across different datasets. You can see various categories from civil comments like toxicity and obscene, and also conversation datasets like Beavertails and Harmless. The numbers show the percentage of labels Docta flagged as potentially wrong. On average, it was over 6%, but you can see it varies quite a bit. Some were lower, around 2%, but others like Harmless and Red Team were much higher, over 15 and 12%. So it really highlights the extent of the error problem. Okay, so we saw the overall error rates, but what do these errors actually look like? This next table gives us some concrete examples from different datasets like civil comments and Anthropic Harmless. It shows the original label, say toxic or harmless, and then the corrected label that Docta identified, like non-toxic or harmful. You can see cases where, pretty clearly harmful or unsafe content was mislabeled originally. It really drives home the kind of subtle, and sometimes not so subtle, mistakes lurking in these datasets that the tool can catch. Right, so seeing those examples really shows the kind of errors Docta can find. But how much does fixing them actually improve the overall dataset quality? This table here focuses on the civil comments dataset and measures that improvement. It uses a metric they call credibility, basically a score out of 100, where higher means better quality data. If you look at the before row, the scores are okay, mostly in the 70s. But then look at the after row, after Docta cleaned things up. The credibility scores jump up significantly across all categories, like toxicity goes from 73.6 to 80.0, and identity attack goes way up from 77.0 to 86.3. It shows that fixing those errors we saw, those percentages at the bottom, really does make the dataset more trustworthy. Okay, so we saw that Docta makes the civil comments dataset itself more credible, but does that actually help the models trained on it? Well, this table shows exactly that. It looks at the performance, specifically the F1 score, for models like BERT and GPT-2, trained on either the original raw data or the Docta cleaned data. And you can see pretty clearly, the scores for models trained on the Docta data are consistently higher across almost all the different comment labels. Like for BERT classifying toxicity, the F1 score jumps from about 69.8 to 73.5 when using the clean data. So cleaning the data really leads to models that perform better in practice. Okay, so we saw that cleaning the civil comments data helped models like BERT and GPT-2 perform better on those specific tasks. And this table extends that idea to the conversation datasets we mentioned earlier, like Beavertails and Harmless. Here we're looking at test accuracy instead of F1 score, but the story is pretty much the same, whether it's BERT or GPT-2. Training on the Docta clean data consistently leads to higher accuracy compared to training on the original raw data. Look at the Harmless dataset for BERT. Accuracy jumps from under 50% to over 68% on the IID test set. It really shows the impact across different types of safety data. So we've seen Docta improves data quality and model performance, but cleaning data manually is expensive. This last table looks at exactly that, the potential cost reduction. It's based on a controlled experiment using the civil comments toxicity data. They compare the effort needed using the Docta label cleaning algorithm versus purely human effort. The key takeaway is in the last column. Docta could potentially reduce the cost or human effort needed to find these toxic label errors by about 90%. That's a huge saving, making large-scale data cleaning much more feasible. So yeah, a potential 90% cost reduction is pretty significant. Overall, this Docta paper really highlights how even widely used safety datasets can have credibility issues, but importantly, it offers an automated way to find and fix them. This leads to better models and makes large-scale data improvement much more feasible. That's really crucial as we rely more on these datasets to build safer AI systems. Well, that's all for today's episode. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.